This is lesson 8.3b, Reflecting and Translating. Our essential question for today: how can I write equations of different functions involving transformations and reflections? Our first question is, how do I show a translation of a function using an equation? We can write our function like this: f of x, and then plus or minus h, and then plus or minus k. Plus or minus h will tell us how much we go left or right. If it is a plus, we go left. If it is a minus, we go right. Over here, the plus or minus k tells us how much the function will go up or down. To make it go up will be plus, to make it go down is minus. For this next part, we're only going to worry about a reflection over the x-axis. So how do we show a reflection over the x-axis? We have our same function, only now if we put a negative out front right here, that is going to cause it to flip over the x-axis. So in this next one, we need to, given the graph, write the description of the transformation and the equation. And this first one, if you remember, is a quadratic equation. And so we need to remember what the parent function of that would look like. So the origin would be where the vertex is, right at the origin. And it'd be a U shape going upwards. That is the parent graph of a quadratic. So we need to figure out how this example A is different than the original parent function. Right away when looking at this example, we can see that the U shape looks like it is opening downwards, which means it has flipped over the x-axis. We can also see that it looks as though the vertex has been moved from 0, 0 up 3. Now to write the equation, we know for quadratic we need to have x squared. There are a few things we need to pay attention to though, besides just having an x with a squared. We need to know if our graph went left or right at all, which in this case it did not, so we can do x squared without anything in the parentheses. We also need to pay attention to if our graph went up or down at all. If we look at our graph, we can see it went up 3. And to go up 3, we need to have a plus 3 on the outside there. Now the other thing that we wrote was that it was flipped over the x-axis. So to show that in our equation, we put a negative out front. And here's the equation that represents the graph that they gave us. Given the description, write the equation and sketch the graph. So this is absolute value. That tells us we're going to need absolute value bars. So y equals and some absolute value bars. Flip over the x tells us we need a negative out front. Next we need our equation to show right 4. So to go right 4, let's look back up at our equation. Right 4 tells us to go to the right, we need a negative in our equation. And in the parentheses. So we go down in the parentheses and write x minus 4. So far we have shown that it is going to flip with the negative, and it's going to go right 4 by having x minus 4. Now just like in our example before, we went up 3, so we just put a plus 3 at the end of our equation here. So for this one, to go down 1, we just need to do a minus 1, and then that is our equation. When graphing, I find it helpful to think about where the vertex would be. On an absolute value parent function, the vertex is at the origin, which is 0, 0, so right here. Now for this example, we need to go to the right 4 and down 1, so 1, 2, 3, 4, down 1 would be right here for our vertex. The parent function of an absolute value would look something like this over here. You see how it's opening upward, So for ours, we know it is flipped, so we want it to open downwards. So something like that. Given the equation, write the description and sketch the graph. In this first one, we see the absolute value bars, and then there's a negative out front right here, which tells us it's going to flip over the x. So we can write that, flip over x-axis. Next, we see a -4 on the inside. That tells us that we will go right 4. And then on the end, outside of any parentheses or bars, we have that -2, so that tells us we will go down 2. Down 2. To sketch a graph of this, we start at 0, 0, and we're going to go right 4 and down 2. So right there. That's where our vertex will be. Flip over x tells us it needs to open downwards instead of upwards. For b, we can see that it is a quadratic. It has x squared, and the only transformation that's happening is +3, so we know it will go up 3. To sketch our graph of this, normally the vertex of a quadratic parent function would be at 0, 0. This has gone up 3, so starting at 0, we go up 1, 2, 3, which means our vertex is here. Now the transformations took place, so it will still be opening upward. Quadratic is a parabola, which is the U shape. This concludes lesson 8.3b.